All right, guys, wanted to give you a little video here on rational expressions day 2, where we add and subtract these rational expressions. So here it says, number 1, perform the indicated operation and simplify the result. So remember, when we add fractions, we have to have common denominators. In this case, we do. Okay, so if I get my pen here, this one, we have both 2x plus 5 and 2x plus 5 as our denominator, so I can just add the tops together. And when I do that, when I put those tops together, I'm still going to write this in polynomial form, so 2x squared plus x, and then I can combine my -4 and +3 to be -1. All right, that's all going to be over 2x plus 5, just like that, and that is how we would leave this one. Okay, now that one cannot be simplified anymore. Okay, what about number 2? Let me extend this page a little bit. Number 2, again, they have common denominators, but you have to be a little bit careful here because instead of just adding those together like we did in the last one, here we are subtracting. So, oops, there we go. So what you should be thinking is that this is almost in parentheses and you're distributing this -1 into that part because it's minus all of that. Okay, so to write the top, I would say it's actually x minus 3x minus 2, and then that's all over x minus 3, our common denominator. Okay, however, x minus 3x is -2x, and -2x minus 2 on top over x minus 3 on the bottom is how we would leave this one. All right, so sometimes they are not common denominators that they give us, and we have to find least common multiples to help us find those. So in examples 3 and 4 here, we just want to find the least common multiples or LCMs of both of these terms, and that will help us later when they're given in denominators. I don't know what I just did on that. There we go. So if you think of x plus 3, okay, x plus 3 just the singular, or I should say the binomial, and then x squared minus 9, we know that can factor to be x plus 3 and x minus 3. So if I change x squared minus 9 to look like x plus 3, x minus 3, and I know x plus 3 is just x plus 3, what this is missing that this one has is an x minus 3. So a common multiple of this would be x plus 3 times x minus 3. X plus 3 times x minus 3. Okay, these might start to make more sense when we actually do the problem, but for right now, this is our least common multiple. Let's see if we can maybe understand this better with number 4. All right, in number 4, again, if I break this down using factoring, x squared minus 3x minus 10, this can break down to be x minus 5 and x plus 2. Okay, and for x squared plus 5x plus 6, this can factor to x, let's see, plus 2, x plus 3, x plus 2, x plus 3. All right, so if you look at what these each have, they each have an x plus 2. So what we need to do is we need to multiply each one by what they don't have. Okay, so for example, I'm seeing over here, this one has an x plus 3, but this one doesn't. So I would have to multiply this one times x plus 3. Likewise, before this one had an x minus 5 and this one doesn't. So I would multiply this one times x minus 5. So if I write out the 3 factors that make up the least common multiple, it would be an x plus 3, an x plus 2, and an x minus 5. Okay, multiply those all together, and that would be the least common multiple of those 2 polynomials. So that's going to be helpful when we get a problem like number 5. Number 5 here, we have an x plus 4 and an x minus 2 as our 2 denominators. So of course, those are not the same. So what we need to do, since if you want to think of this as our binomials, this one doesn't have the x minus 2, and this one does. So I'm going to multiply this one times x minus 2. But I can't just do that. Okay, I can't just do that to the problem. I have to do it to both the bottom and the top if I want it to be an okay math move. And the reason why we do it to both the top and the bottom is because if you would just take this part separately, x minus 2 over x minus 2 would be 1. And if we multiply something times 1, that does not change it. All right. So likewise, we have to take these x plus 4, which this one does not have, and multiply it times our right side. And you have to do it to both the top and the bottom. X plus 4 over x plus 4. Okay, so then we have to actually do the multiplication and see what this gives us. Okay, so on the top left, if I have, let's see, if I have x minus 2 times x minus 3, that is going to multiply to be x squared. X times negative 3 is negative 3x, and then negative 2 times x is negative 2x, so that's minus 5x. And negative 2 times negative 3 is a positive 6. That's on my top left part. And then on my top right part, so I'm going to say plus, the top right part is x times x plus 4. Well, I can distribute that in and get x squared plus 4x. And then now, the nice part about these is that we got those common denominators. This is both over x minus 2 times x plus 4. Oops, x plus 4. And the same thing on this side, x minus 2 times x plus 4. All right, so then I can just add those tops together and see what that gives us. Okay, so it's going to be x, let's see, x squared plus x squared. For my x squared terms is 2x squared. And then my x terms, negative 5x plus 4x is negative x. And then plus 6, that doesn't add to anything, so it just stays plus 6. Okay, that's going to be all over x minus 2 times x plus 4, my common denominator. Okay, so it's a little trickier than multiplying, but the same concepts, except for the common denominator is the new part today. Let's try it with number 6. Number 6, I'm seeing that this one, our least common denominator, is a bit trickier because we have to think that this x squared minus 4 is actually x plus 2 times x minus 2, that difference of squares. Okay, and unfortunately, the other side, just x, doesn't have either of those two factors. So we have to multiply this side times both x plus 2 and x minus 2. And that's both on the top and the bottom. X plus 2, oops, over or times x minus 2. Okay, what the left side doesn't have is the x, is just the x itself. So I multiply this times x and this times x. And you know what? I should actually leave that as x plus 2, x minus 2, because that is, we eventually want to factor our bottom. All right, what does that do for me? On the top left, that's going to be, it's going to be x to the third power. X times x to the second is x to the third. On the top right, negative 1 times this is just, I'm going to keep my negative out here, and it's going to be, well, 1 times those two is just still x plus 2, x minus 2. Okay, and that's still all over x times x plus 2, x minus 2. Now, yesterday we canceled our x plus 2 is x plus 2, but we can't do that today because this negative sign kind of glues that to this x cubed. All right, so unfortunately we cannot just start canceling things. What I have to do on the top is do the multiplication and see what I get. Okay, so again, order of operations, multiplication comes before subtraction. So I have to FOIL this. It's going to be, let's see, so I'll keep my x to the third out here, minus, and then x times x is x squared. X times negative 2 is negative 2x. And actually, this is just a difference of squares. So this would come back together, I'm sorry, as x squared minus 4. Okay. Still over my common denominator bottom, x times x plus 2, x minus 2. But on top now, I'm going to distribute that negative from the outside in, and that's going to be x to the third minus x squared plus 4 Now all over my common denominator bottom, which is x plus 2, x minus 2. Okay, and I think that is as simplified as that one gets. Let's try a couple more. Number 7 and 8, and that should be good. So number 7, this one, again, you want to start by factoring your bottoms and see if we have anything in common. So this was simplified to be what, x plus 2, x plus 1. And this side is a difference of squares, x plus 1, x minus 1. Just like that. So they do have an x plus 1 in common, which means all I have to multiply by is the factor that they don't have in common. So on my left side, this one on the bottom does not have the x minus 1. So I have to multiply that whole side by x minus 1 over itself. X minus 1, x minus 1. And similarly, on the right side, this one doesn't have the x plus 2. So I have to multiply the top and the bottom by x plus 2 over x plus 2. Okay, and we'll do the multiplication and see what this gives us. On the top, it's just going to be x squared minus x over our common denominator bottoms, plus on the right side, let's see, that'd be 2x squared. And then x, or 2x times 2 is 4x. Negative 3 times x is negative 3x, so I think that's just plus x. And then negative 3 times 2 is negative 6. If you have to write that extra step and then combine your middles, that's fine. If you can do it in your head, that's also okay. Oops, plus x minus 6. Sorry, erased that on me there. Okay, and those are both over our common denominators. I'm just going to put these all together once as x minus 1, x plus 2, and x plus 1. All right, and then all I have to do is add the tops together and keep it over that common denominator. So on top, we have x squared plus 2x squared is 3x squared. Negative x plus x cancels, and then just minus 6. Okay, and then on the bottom, we're going to have x minus 1, x plus 2, and x plus 1. Okay, and that is how you would write your answer. All right, last problem, number 8. Number 8 says 3 over x squared plus x minus x plus 4 over x squared plus 2x plus 1. Okay, again, I think all I can do on this one is factor out an x, giving me x plus 1. But on this one, I can get, what is that, x plus 1, x plus 1. Okay. So again, a couple things here. What this side doesn't have, what the left side doesn't have is another x plus 1. You do need both, even though it has one of them, you need 2, just like this one has 2. So it needs another x plus 1, and on top, again, times x plus 1. And the reason we do that is because x plus 1 over x plus 1 equals 1, and you can multiply something times 1 and not change it. On the right side, this one doesn't have that extra x. So I'm going to go x over x, x over x. And what does this do for me on the top left? That's just going to be 3x plus 3. Okay, and then on the bottom, x plus 1, x plus 1. Minus, on the top right, x, if you think about this in parentheses and you're distributing this in, this is x squared plus 4x, again over my common denominator x times x plus 1, x plus 1. Okay, and so let's see, that would be, if we write our largest exponents first, I only have one term that's an x squared, but remember this is a negative, so you have to distribute this negative in. So it's actually negative x squared, or negative 1x squared. Then next will be my x's, and then I have 3x minus 4x is negative x. Okay, and then just a positive 3 minus nothing. There's no constant term over here, so just plus 3 over our common denominator of x, and then x plus 1 times x plus 1, or Since those are the same, you could write x plus 1 quantity squared. Okay, either way works. All right, and there you have it. This is adding and subtracting those rational